We're live. This is Made Up of Wires. We've been decompiling Castlevania Symphony of the Night. We're going to continue doing that today. We're working on the first of two weapon objects that ship with the game. This is where all the code for weapons are stored, along with the different animations and things like that. There's at least 200 weapons in Castlevania Symphony of the Night, but many of them use the same code, and there's about 110 or so different sets of functions for those weapons. If you're not familiar with the Castlevania Symphony of the Night decompilation project, you can go to SOTN.z.dev to see what the progress is. You can get a link to GitHub where any of our decompiled code will be uploaded, and you can also get a link to the Discord server where we're talking about decompilation, ROM hacking, PlayStation SDK, things like that, compilers, MIPS, lots of different things related to the ecosystem that is this project. If you go to the status page, you're going to see different files that we're currently working on. So when we decompile a program, or in this case a game, what we want to do is create source code that will compile back and create a bit-perfect copy of what was shipped in the game. Once we have source code for a game, that source code can be modified easily by other people in the community who want to make ROM hacks or mods to the game. There's an entire randomizer community that's involved in running tournaments and speedrunning. But it also allows us to port the game to other platforms, and so we're interested in that as well. I think later, when weapons are finished up, I may take a crack again at this last function in the Dracula game engine. There's one function left here for that to be code complete. The Richter program is complete. As I mentioned earlier, we're working on weapons. We started weapon 001, which is a bunch of the punches, and we're going to continue that today. And I don't have a lot of time today to decompile live, but I'm hoping that we get most of the way done, and we may get a match here. I worked on it a little bit this morning, and it's pretty close. Actually, I should refresh this page. These weapon numbers should be a little further along. Yeah, so there's 4 weapon functions left. I keep a countdown of the weapons, and we have 4 left. We're going to work on one of those today, and maybe tomorrow we'll have 3. There's several of the stages, and many of those have been completely decompiled as well. I don't believe any of these are portable yet. By portable, I mean all of the data also has been referenced in a way that makes it relocatable. Once that is the case, then modding becomes very easy because we don't have to worry about offsets in files. We can recompile that object, and anything that relies on an offset will automatically get updated at compile time. I'm going to hop into Scratch and just kind of back up a little bit and describe what we were doing yesterday and continue on. So weapon 001 is, like I mentioned, is many of the punches. I have Alucard here doing punches. We're working on the entity weapon attack function, which is the primary attack function that gets called by the game engine when you hit one of the attack actions, either square or circle. So we were in the process of it. I'm flipping between, this is the PlayStation version of the game. We also have the PSP version of the game, and I'm flipping between the two, and as I'm making changes to one, I'm pasting the code over to the other and seeing how close the match is. In decomp.me, we have our code editor. On the left, the middle column here is our target assembly, so what the original game, how that was shipped. And then on the right we have what the C code that we're editing, what it's compiling to, and then there's a little gutter in the middle here that tells us where the differences exist and what type of difference they are. When I left yesterday, the PSP version was somewhere in the low 90s for a match in terms of percentage. This percentage is a Levenstein distance of the string values of these assembly. So Levenstein distance is looking at two strings and comparing how many edits are necessary to make those strings the same. So it's a okay metric to use, but we do need to look at things a little more closely than just looking at a number to see if we're doing better or worse. And that's kind of the stage that we're in now. This number may fluctuate up and down towards the end of this decompile as we go. There's several differences between the two that I'm not going to focus on, at least not yet, because either they're things that I can't control directly, like register allocation or stack allocation, or they're intentional differences, such as these immediate values where the PSP version, when it's extracted, the symbol name wasn't mapped, so we just get an address, but when we're compiling it from our code, we do have symbol names that the compiler will stick in there. So those differences will show up, but they're not relevant. The code between the PlayStation version and the PlayStation Portable version typically is 99% the same. Occasionally we'll need some macros to differentiate some code, include some code in one and not the other. But for the most part, they're pretty identical. The PlayStation version and the PSP version are compiled with different compilers, and those compilers have different characteristics. So we have GCC with standard optimization for the PlayStation, and for weapon overlays in the PSP, we're using MetroWorks without any optimization. Without any optimization, we get much more assembly, and that assembly tends to be more literal, and the way registers are allocated tends to be more liberal in using more registers when that might not necessarily be required. And then on the GCC side, we see more out-of-order code execution. We see chunks of code that are deduplicated and then branched to in ways that aren't necessarily obvious if you were just reading the C code. And so we can go between those and get hints from both of those to try to come to a final solution. What's interesting, and I haven't spent a significant amount of time looking at it primarily because we haven't mapped a lot of symbols there, but we also have a Xbox 360 version of this, which is PowerPC code. I haven't spent a lot of time digging in. There is a rough Ghidra decompile of that, where you can kind of find some of the matching functions, but I do think it would be interesting at some point to go through and start extracting the PowerPC code that was compiled for the Xbox 360 and compare that. There's some interesting things there that I think would be good to cover in a future stream. What's nice about that version is that it's based on the PlayStation version with a few differences, as opposed to the PSP version, which later releases, like the Requiem and iOS and Android versions are based on. Okay, so getting back to Weapon 01, the PlayStation side was actually not matching very well. And what I found yesterday after I got off the stream is the way that the cases were set up here was on the PSP side was producing the correct code in order, but where the switches were branching to was not correct. And so you could scan through the assembly, and in the correct order you would see effectively all of the same instructions operating on mostly the same values, with the exception of registers, which are mismatched, which happens a lot on the PSP. But what was missing was that many of the branches and jumps to specific offsets were wrong. And what I did to try to figure out how to correct those was go through, and in the editor we have these squiggly arrows which tell us that there's some code or some earlier branch that's jumping to this location. And I noticed that there were target offsets in my version of this that didn't exist in the retail version, which led me to try to investigate where that was happening. And what I found was I had cases that were wrong. So for example, instead of having the case here, this code up here may have been outside of this case statement and been its own case 5. I don't know if this is going to produce a similar outcome to what I was seeing before. It does, actually. So we effectively generate all of the same instructions, and just scanning through and looking at what instructions are off here, we don't see that. In the case of this PSP version, I don't have offsets for the master switch statement that is driving this state machine. So occasionally, though, we will find that there are branch points that are incorrect. Either the target of a branch is wrong, or we're branching into code where the original never was branching into that area. So let me fix that back up. I'm going to continue on looking for some of these differences, trying to identify areas, and I'm going to flip back and forth and see, probably use the PlayStation version to identify larger areas of change, and then maybe flip back to the PSP version to fix those things, and then copy back. I noticed this when I was looking at the PSP version. There is a constant value here, 16, where the original had a 4. That's an odd mistake to have made. Yeah, I'm not sure how that ended up falling in there. I first saw Josh, who's somebody else working on decompilation, do this, but I think it's a really nice way to pull those constants out, because we use that the count of primitives over and over throughout the function. So primitives are allocated, in this case, when the attack starts. They're assigned to an entity which then manages the lifetime of those primitives. And this is kind of the state machine that walks through either that animation or how to draw and choose colors for those primitives. So that was a small change, but it is something that gets us a little bit closer. So I'm going to just scan down here. So I see down somewhere around line 50. This is somewhat of a not straightforward instruction to fix. Optimize GCC will take a bunch of lines that are related to setting up a for loop, for example, and just kind of stuff them all into a preamble for this loop. And so it's difficult to determine. So for example, this array that is being accessed much further down in the assembly, its address is being loaded into a register at the start of this for loop, because GCC has determined this address is being accessed every time we enter this array, every iteration of this array. I'm just going to load this address once, and since it's a constant value, I can refer to that register going forward. So many of these values are the same. It's loading several constants. In this case, this A0 constant here is being loaded out of order. And I don't see an obvious reason why, but we can flip over to the PSP version, and that might give us some additional insight. What's nice here is that the PSP version should follow a relatively linear order for its assembly instructions. So as we go line by line, we're seeing on the right hand side here, the assembly matches exactly in the order that we are evaluating in. So we see some register differences here. Those will be different. The first one, though, that I notice is that this S3 value, which is a 0, is, or I in this case, is being used in hours, where V1 is being used here. So that may be the wrong value. So this is a mask. So in this case, we're masking the value of offset 34 in this primitive, and then that's going to be stored at offset 1C. Whereas in ours, we're storing, so ours is storing I. This looks like it's maybe as simple as this, yeah. And that's great, because that cleaned up a whole bunch of registers. So this was a assignment that just was missed. So let's take that back over. And amazingly, for the PlayStation version, that was basically the thing that was preventing it from... oh no, I got rid of my... my primitive count constant. So I'm going to do that again. I'm going to replace that here. Hopefully we'll see these registers clean up like we did before, and then copy that over. And these are the best case scenario. One small change like that, so this was an assignment of a wrong value. The value was in a register that looked very similar to the register that this I variable was using. But fixing that fixes a host of other problems, which is great. So now I want to go through the PlayStation version and look at what the remaining differences are when we get around 99%. The the remaining differences may just be immediate differences, so where we have a symbol name that's different from the extracted assembly symbol name. Or it could be something else, something out of order or otherwise. So I'm just going to go through and scan. What I want to see is, on the PlayStation version specifically, a pair of immediate values that differ from the original. If it's a pair like this, these 32-bit address values are loaded in 2 instructions. Typically that's fine, and we'll get a match, even though it doesn't match in decomp.me. I can go into more details. Along the way, as I'm scanning through this, if there's any questions, comments, concerns, feel free to chat, and I will address anything I can along the way. So here's the first difference that I see that we may still need to resolve. These RO data markers are indicating that different parts of the switch statement are falling there. So when we hit case 0, in this case, offset 4 represents case 1, offset 8 represents case 2, etc. When the switch is branching into these particular cases of the switch, we'll get a marker here. So we have an equivalent marker down here, which matches. And then down here, we don't match. And not only that, but we're missing one down below, and that's duplicated up here. So we need to figure out what is causing that. I added this case 6 because it was explicitly called out. The case 6 doesn't do anything other than if there was a default value here. So I'm a little surprised that GCC generates a branch to that offset, but it actually might be the same offset as the default case. So let's, that looks like that may have been the remaining issue. Let's copy that over here and see. There's still some issues on the PSP side. I want to look at the branches there and just make sure that the MetroWorks compiler didn't introduce something that I wasn't expecting. And it doesn't look like it did. So let's continue on. What can we say about MetroWorks? I don't know if there's a subculture that's ready for MetroWorks memes. Maybe there is. Maybe there is. So we're seeing more immediate value differences. This one's a little curious because GCC decided not to put these as consecutive instructions. I don't know why. That's kind of an odd pattern. It happens sometimes, but is a little strange to see. All right, so I was working on this earlier and scratching my head over it. This is one of those things where I'm new to the decomp community in general. I've been just underground on my own, plugging away at Motorola 68K assembly and things like that, and kind of self-taught in doing these things. So this, starting in May, basically is my first experience with a more comprehensive decompile like this, and I haven't spent a lot of time looking at the other projects, other things like that. So there's a lot for me to learn. Okay, so this is somewhat curious. I'm going to flip over to the PSP version and see if I can get any more info here, because yeah, I was banging my head earlier about this. There is a when we hit this else block, and it actually happens. Is it down here? Yeah. There is a flipped argument that seems related to these statements, and I have been permuting this a bunch of different ways and failing. So I'm going to flip over to. So what will happen? And actually, this probably isn't here, but probably down here. Maybe not 590. Possibly. Yeah, so this is kind of an odd... yeah, I can try the Nuix minus rand. What is... when you're looking at MIPS assembly, and you see a branch instruction like this here on line 179, the instruction immediately following it is going to be executed regardless of whether that branch is taken. In this case, it's a jump, so it's a non-conditional statement, but we'll see other things up here, like a branch not equal to 0, which is conditional, and the instruction immediately after it will be executed regardless. So we jump here, and logically, if you're reading this, you'll say, okay, on line or offset 568, I'm going to jump down to 590. You're going to jump down to 590, but you're also going to execute offset 568C in the process. And so this this instruction is more likely related to what's happening down here at 590 than it is up here. And 590 is, this is our instruction here. But like I said, I'm going to go over to the PSP side and see. The PSP side, this might actually not be helpful. The PSP side is, I found in general, less variable about commutative arguments. Yeah, and that can be super confusing. So I talked about this a little bit earlier on. Roaming is saying it's a precursor to some of the other stuff. If you look at for statements, for example, and the way GCC, optimized GCC, generates these for loops, like there is instructions scattered all over the place. And some of these have to do with what it's going to execute during the branch. It's doing this multiply by 4 somewhere in there. This multiply by 4 is happening in here, and it knows that when it branches, it's going to do that eventually. Optimizers are wild things. Okay, so going back over to the PSP version, this might not be as helpful as I was hoping, but there's a bunch of mess here, which may or may not be helpful. We'll see. I'm a little surprised at some of these. So up on line 157, I think I've flipped these back and forth, and I'll try flipping them back again. There is a store of this value. Our code is storing a 16-bit value. Store half is the mnemonic there. The original is storing, is doing a sign extension and then storing the value. which means that it's storing it into a 32-bit value. I'm going to try switching those. That ends up causing other problems. So there's something going on there that needs to be resolved. The GCC side doesn't have that issue. Whatever is going on, GCC has determined that 16 bits or 32 bits, whichever side it ended up falling on, is fine for all of the operations, and optimal. So I'm gonna go down here though and try to figure out this this argument switch. We do see it here too, so that's good. This subtraction does appear to be in the wrong order. Maybe it's as simple as this being a minus 16. Nope, of course it's not that simple, because it never is. Yes, you do have to be careful, and that's a bigger issue on. So the question is, do you have to be worried about variables being optimized into registers, or is everything on the stack? When looking at the PSP decompilation, so this is at no optimization. The biggest amount of differences that we see, and that still exist, most of them have been cleaned up, but are register assignment. I don't think there are any stack versus register issues remaining in this one, but we have stack offset differences. Yeah, having a no optimized version is super nice. Really verbose assembly, but nice to see. Okay, so let me try to. What did I do here? Let's see, get that back to where I was, and we're down on line 177. So we have this subtraction, and our arguments are flipped. So let's try flipping. And that looks like that was the issue. And so to match, let's pull that up here. So there are still issues here. This is I had changed this earlier. What is interesting about the MetroWorks compiler is how at zero optimization, how it treats these zero equality checks in a condition. So if you, as programmers, we think not player facing left is equivalent to player facing left equals 0, and logically they're going to do the same thing, but MetroWorks is going to produce different code for those code paths. On the GCC side, the code is the same. Maybe at zero optimization it's different, but that's not what we're trying to match. So it looks like that ordering is fixed. I'm going to go back over to the PlayStation side. Ooh, PlayStation was not happy with that change. So what happened here is a result of the optimizer. So it looks like GCC saw that regardless of the branch that it took, I'm going to go back to what this was prior to that change, even though it's wrong. When written like this, for whatever reason, GCC has decided that it is not going to take this out and optimize it. So regardless of what branch is taken along the way here, this call to rand with the mask and then the plus 16 is going to get executed. And when we may be able to fake it and fool GCC by changing this, but no, that's not... oh no, the rand is still being duplicated there. What are we pulling out instead? We're pulling out this addition. There we go. Grouping is your friend. So, my mistake. I was grouped inappropriately. So that ordering now is correct. In this case, the mods are a pain to determine what the masks versus mods and division, things like that. The instructions that get generated for those are wild, and I usually bang my head against the wall trying to figure that out. On the GCC side, especially, the way that those are optimized and the fast path values that get generated there are crazy. I would like to at some point find that section of the GCC optimizer in code and see if we can decipher some of those tables. Just having a wiki or something that says, like, if you see hex 667, or what have I seen before, like 6667, 6667, with like a multiply with overflow and all these other things. If you see these values, it's going to be a mod by 12 or whatever it ended up being. I don't know. Okay, so that looks pretty good on the PlayStation side. Fortunately, I only have a little bit of time left, and so this might get us to where we need to be. On the PSP side, we're still in a little bit of trouble. A lot of register mismatches. Some of that may be due to ordering. There's odd things about how variables are declared in the order then that they're stored on the stack. That's what my notation up here is for, is trying to figure out which register each of these was originally, and then tweak the ordering there. The register values are less sensitive to that. Those seem to be related more to how they're the order that they're used in code, but the stack values seem like they're influenced by the order that they're declared at the top of the function. Let's see. Sorry, doing doing chat admin. LMAO is apparently too offensive for chat. I appreciate the filter, but maybe a little too restrictive. Okay, so kind of getting back to the progress. I want to scan through again, make sure the only difference now is that these immediate values are different on the PlayStation side. I may spend a little time later today looking at the PSP side again and see if I can resolve some of the register issues. The goal of the project in general is to have a code base that is compilable for all versions of the game. And so optimally, we would get a PSP decompile at the same time that we get a PlayStation decompile. No work has been started on getting the weapon module compiled for PSP yet. So while it would be nice, we have a ton of weapon code that is going to need to be worked on to get it into a state that's compatible with PSP as well. So I'm not terribly concerned about that. That is one of the interesting things, I think, if we start integrating a PowerPC build in as well, comparing the Xbox 360, is the code that we have that is already matching in PlayStation and already matching on PSP. Is that going to slot right in and also match for PowerPC builds? So yeah, I don't see anything, any other issues with the PlayStation version. So let's take that over and see if we get a match. So in the code base, we have these macros that pull in the assembly for functions where we've not decompiled them yet. So I'm going to replace that with the function from scratch, and the build succeeds. We have a match, so that's great. As I mentioned earlier, there is 4 weapon functions remaining. I have some work to do to clean this one up. We can throw a little party for ourselves. But now we're down to 3. This was one that I started several weeks ago. Had some struggles with, primarily around the logic in the middle here, which is very verbose, very repeated, but it seems to have worked out. So I'm glad to get that one done. I'm going to just make sure that this is in sync one more time. Really odd that there is so much mismatch. Like I said, though, there's some... this is a hint where we may have a variable that didn't exist in the original version, and the GCC optimized version will just punt on that variable and not worry about it, whereas ours, we have to be more careful about it. So we're loading a value at offset 3A down here on this line, which may be is that the Y offset? Yeah. So this value is getting stored on the stack, and then being reloaded here in ours. But in the original, it's being stored in a register. So roaming, to get back to your comment earlier, this is exactly one of those issues where MetroWorks didn't pull this out in our version. It didn't pull it out into a register. I'm going to separate those. Usually they're the same type, and so I declare them the same way. I'm interested in if Y offset by itself is a 32-bit, if that helps. Otherwise, I'm not going to spend too much time down here. If I can get an easy win, I'll take it. No, it's storing the word here. This is curious. I've done this a couple different ways, where I mean, I'd like to just pull this down here because the Y offset isn't used otherwise. But this code is executing in this order. There's nothing that I can do about that. So my guess is that there's some other register pressure that's preventing, in this case, S2 from being used. So, oh, I don't have enough screen to monitor OBS. Okay, so getting back to chat. The efforts are focused on both game code and SDK. So when PlayStation games are compiled, Roaming, you're probably familiar with this, but I'm going to say this more for the general audience. When PSP games or PlayStation games are compiled, one of the things that appears on the disk is a bunch of code that came from the PlayStation SDK that was used at the time that game was compiled. So in the case of Castlevania Symphony of the Night, let me go to the PlayStation version, we're using SciQ 3.6, I believe, but GCC version 2.6.3, or maybe it's, sorry, SciQ 3.5 with GCC 2.6.3. I should actually get the same compilation with this. I don't, but I'm not worried about that. So part of the entry point on the CD, which is SLU 00067 for Castlevania Symphony of the Night, you execute a main function that has a stub, which loads another file from the disk, which is the dra.bin at a particular address, and then goes from there. dra.bin, in turn, references back to different addresses in that main entry point program, which contains functions from the SDK that was compiled with for the game. So, long story short, we are working on this particular version of the PlayStation SDK. One of the members who is now working on, oh, I forget what game he started working on. He's working on a different game as well. He's working on a slightly different version of the SDK, and he's built some tooling actually to try to compare what version of the SDK the game might be using to narrow down the one that he's using on the second game. Sozu D, who is a major contributor to the Symphony of the Night decompilation project, has a separate project as well, where he is providing decompiled PlayStation SDK versions, SciQ versions. Okay, so Daniel, how far along is the project currently? You can go to soten.z.dev to see what the current status is. We have 10 or 12 of the binary files that are in flight. The main game engine has one function remaining, but then a bunch of data. The Richter portion, so there's different overlays in the game. So one game engine, there's Richter, Maria, Alucard programs for the player character. The Richter program is the furthest along. It's been completely decompiled, and all of the data related to it has been referenced in a way that it can be recompiled for different platforms now, which is exciting. We're working on weapons here. There's after today there'll be 3 weapon functions remaining in the first of 2 weapon modules. We haven't started the second yet. And then there's several stages. I think we have 1, 2, 3, 4, 5, 6, 8-ish stages and one of the familiars. We started on 8 of the stages. There are maybe 5 of those that are completely decompiled from a code perspective, but I don't believe any of those have completely been had their data and other things referenced in a way that makes them relocatable. So it's still early. There's quite a bit of time left still, but as we get further along, one of the things that happened a few months ago is a lot of sharing of the code between stages, and now that we have extracted that into shareable header files, new stages can come in, and a lot of the code is duplicated between stages. And so we don't have to do as much work to decompile new things as they come in. Roaming asks, O0 means no inlines. Yeah, so any code that's duplicated is duplicated, which is nice. I'm going to, do I have, all right. I think that's all the chat questions. So yeah, kind of backing up, we got a match. When you're working on a project with lots of other people, and you want to make sure that this change is useful and usable for the project, there's other things that need to be done. I need to go through and update flags, for example. I just recently wrote a tool to do exactly that. We can go through and before we had to write or masks to reproduce these from constants. Now we have a tool that'll go through and find all those and replace them. So I don't have to do that anymore. There's a few other things that may need to be... We have unions that sometimes the decompiler chooses the wrong side of the union. So there's cleanup that I still have to do. So it's not perfect yet, but it's matching, and that's the hardest part, really. So kind of closing off, it's an early day for me. I have kids that have early release and other things like that, so I need to get going for the day. But if you want to know more about the project or are interested in contributing, interested in decompiling, you can go to SOTN.z.dev. You can get a link to our GitHub repo, and sometimes I'll pull that up, especially when I'm... I like looking at headers just in my terminal, but it's a good place to go and just kind of browse around and see what the structure of the project is and what we've done so far. There's also a link to the Discord server. I seem to be, in general, offset on the Discord server from when other people are active, but I'm on there every day. A lot of the people on the stream are on there as well. And there's some crossover between Long Library, which is where a lot of the speedrunning and randomization community hangs out, and the Decomp Discord as well. So yeah, if you're interested, feel free to stop by there. There was a request earlier to kind of give a tutorial style stream. I would like to do that. And if there's interest in any particular topic, feel free to chat. Roaming, thanks for stopping by, and feel free to follow. That helps a lot. If you want to see previous streams, I periodically upload these in YouTube and kind of sprinkle them out kind of as a daily replay of some of the older streams. And I tend to stream Monday through Thursday, usually around a set time, for about an hour and a half or so. And whether or not we get to a match during the stream really depends on what we end up working on. So thanks for watching. I'll be back tomorrow, and usually I do something a little different on Thursday. Not sure what I'm going to do for tomorrow yet, but I'll try to come up with something fun that is a little different from just decompiling weapons. Thanks, everybody, and see you tomorrow.